Hello everybody, welcome to a new Bukkit development tutorial. In this tutorial we're going to be making structure detection. An example of what we're going to be making is if I just look at this and do test, you'll see it all turns to wool. We're going to make something like this. As you can see, lava doesn't get turned to wool. You can do this on practically any of these structures. Water stays as well. Yeah, so as you can see, it isn't perfect because of houses like this which have diagonals, but you could add that. But yeah, so as you can see, perfectly adds it, and that's where the torch was, that's where the ladder was. The coloured bits are will data because we didn't reset the data value. If it's a custom data, like if we look at the crops, you'll see it's multicoloured because they have data values. So we're going to be making something like this. So let's hop into Eclipse. Okay, so at the I've got a simple command set up here. This is our test command. And we're going to assume they're not the console. This isn't the proper way to do it. You do if instance of sender is player, then cast it. But we're just going to skip that. So to start with, what we're going to do is we can start by making a function to get the surrounding blocks of a block. So the blocks to the left, the blocks to the right, the blocks forward, backwards, up, down, all them sides. So let's start by we're going to return an array list of the block, and we'll call this function get surrounding. And then we're going to pass in a block. This is going to be the base block, and I'll show you how to do it. So we'll start a return because it's got a return block, and this will be called blocks. So let's just create that. Okay, now once we've created that, we need to import all this stuff. Boop. Boop. Okay, so I'll just show you that I can do block.getRelative, then put the block face in. So what we want to do is we want to make an array of the block faces we want to get. So faces equals new block face array. This is just a simple array, and then we'll end that. And then what we can do in here is we can go block face dot up because we want to get above, we want to get below. This is just simple logic to get all the blocks in each direction. Then what we want to do is we want to go down every direction. We don't want to use these ones because they're going to be diagonals, etc. Never eat. Oops. Shredded wheat. That's how I remember it. And that's all the points we need, and then we'll just import this block face. Okay, now what we want to do is we want to do it for each of these faces. So for block face F in faces, so this is for each block face, we're going to go block B equal, no, we need to call this block, we'll call it S. B dot get relative, so this will get the relative block. So if it's up, it'll get the block above it. If it's down, it'll go down. If it's north, if you think about it sideways, it's forward. Same south as backwards. East is right, and west is left. So for F, then we need to add it to the array. So we need to go blocks add S. Okay, so once we've done that, issue with the code so far. No, I'll just do a demonstration of what's wrong with it. If we called that and then did some magic on all the surrounding blocks, it would return these grass blocks, and we don't really want to have an infinite spread of searching, because we can make this pretty nice. It can lag if it's a big structure there. Oh, zombies breaking down doors. Oops. So what we want to do is we want to exclude certain blocks like gravel, grass, stone, bedrock, etc. They're simple blocks where you'd never build a structure with. So we're going to make a new list of materials, and we're going to have these as our band of blocks. Material list, we'll call it list for now, equals new material array. And this is going to be a simple array of everything. So we've got air, because we don't want to spread through air. We've got grass. We've got dirt. We've got bedrock. We've got gravel. Might as well add sand, because who builds a house out of sand? We've got leaves in case a tree touches it. Well, we're going to include leaves. You might not want to because they might have shrubs or something. Let's include stone. We probably need to include lava and water, because if you don't, generally it can cause huge spreads. So we'll go stationary lava, material dot stationary water. And then we need to get the flowing types, so that's going to be water, material, lava. And that should be all the materials. Okay, so because this is a list, we need to make it so, because if I could show you, you can't do list.contains, because you'd have to go through each one, which is a bit of a hassle. So we're going to be a bit cheating and turn this into an array list. We'll turn it into a list because it's easier. So we're going to turn it into a material list, and we'll call it band because this is our final list. And we'll go arrays dot as list, and this will just simply convert it into a list. And we'll, yeah, so then what we can do is if band.contains s.getType, because that'll get the material. We want to exclude it, so we'll just continue searching so it won't add it. So now what we want to do is simply add a return statement returning our block array. And that's your simple, complicated get surrounding function. Okay, so now what we want to do is we want to get the block the player's looking at. So block B, we'll call it B because we call them B here, equals P dot, and there's a function called get target block. And the first bit, you can just put null. And for the second argument, it's the distance, which I'm going to put to 200. I'm pretty sure the first argument is probably the data value or something like that, or any certain types of blocks. Okay, now this is going to be quite complicated. So we want this to be infinite. So it's going to have a while loop. Don't worry, we'll break out of this. You'll get that error, unreachable code. That's because this will never stop unless we add a break. Okay, so this may sound quite complicated, but what we need to do is we need to create an array list of all the blocks we found. So that's pretty simple. So that's array list block found equals new array list block. So that's very simple. Found. Now, we need to create an array list of blocks to search. Because what we want to happen is this loop here is going to go, it will start off, is going to go for each of the search blocks, it's going to get surrounding blocks, and then it's going to add them to the search blocks, and then when it runs out, it will return the found list. It's quite complicated. So, yeah, let's start. So here, every time this loops, we're just going to, we could put it up here, but we'll just stick it up here. This is good. Well, you'll see how these are used in a few secs. So every time this loops, we want to clear the to search. This is basically just what happens is for each of these search blocks, we fill up the to search array. Then when it's done, we clear the search blocks array and add the. If there's nothing in the to search, we return it because there's no more blocks. But if there is, we add them to the search blocks and it'll loop. We'll see in a minute. We also need to start off, because we need it to start on a searching block B. If you're looking at this one, of course. So for each of the blocks, so we'll call this B2. In search blocks, we want to make sure add them to the found list. I think. Will they have been found before? Let's do a check. If found dot contains B2. If not, then it's going to go found dot add B2, and that'll just add it to the results set. Now what we want to do is we'll just create a temporary list block, and we'll call this fact. And this just gets the surroundings. This is a function we made. So it'll get all the surrounding blocks of B2. This is quite complicated. So for each of them surrounding blocks, we'll put B3 because we've already used B2. So each of the ones we fetch, we're going to check if they're. What'll happen is, I'll just do a quick in-game example. Let's say we have a cube like this, and it searches from this block, so it can go left and find this block, or it can go down. When it goes left, it will also find this block, so it'll add it to the array list. But when it goes down, it'll also find this block and add it. So it'll add it twice, so we need to stop it adding duplicate blocks. So if we've already found it, we don't want to add it again. So if found contains B3 or to search, that means we're about to search it, because we don't want to search it twice, contains B3, then we need to continue, and that'll just skip that. Otherwise, we want to add it to our to search array. Just like that. Okay, so we've got the major. This will just search through it, but it'll be non-stop. So all we need to do is here is if to search, if the array we wanted to search dot size, this will get how many are in the array, equals 0. We want it to break out the array. Otherwise, we're going to clear the blocks we're searching at the minute, and then we're going to add blocks we want to search. So search blocks dot add all, and then we'll just add the to search. Right. And then we'll clear the to search, so next time it goes around, it can find more blocks. Now that may have looked really complicated, but if you get your head around it, you can do anything. So we're going to add a final test array. So for each block in found, we're going to set its type to material.wall. We'll save that, export it, reload our server. You can also add debug searching stuff to tell it that it's still searching. It's useful if you're scanning large things. You just do a system.out of the block and then just give the data shown there. So if we look at this and do test, you'll see it works perfectly. So yeah, that's practically it. So I'll do a quick explanation of a quick overview on how it works. So it starts off by looking through all the blocks we've got in our search array, which contains the block he was looking at. When it finds a block, it adds it to the toSearch array, which later on gets, if it has stuff in it, so if it's found blocks to search, it'll add them to the search blocks and clear it, then look through them, and it'll do this until it runs out of looking for blocks. There are a few cool things you can do with this. I'll just show you one really. Okay, so this is quite a cool thing I've made. It took me half an hour or so to figure out how it. And it'll flip village houses upside down. And I also added stair flipping, so it'll flip all the stair blocks so they're the right way around. It's quite amusing. I'll also add the code for the flipping in the description, so you guys can play around with it on your private servers, etc. It works on practically any house. You can tell I just spend my time doing this. Of course, the code's a bit bulky. If I show you, it'll place the torches after the blocks, and it'll remove them first, so that it doesn't create any falling blocks in general. But it does drop doors, and I didn't advise doing it from. And you can do it to large structures as well. I'll just show you. I'll just flip this over. Oops. You'll see that the ladder still sticks on, because we don't need to flip ladders, because they're already the right way up. So I hope you guys enjoy this tutorial. If you've got suggestions for the next tutorial, please leave them down below. I do appreciate it. Hit up a like if you found this useful. Go and use it in code. Also, if you make a plugin similar to this using the code like Protector of House, send me a message. I'd love to see it. So see you in the next tutorial.